In 2023, one of the worst natural disasters in Ohio history occurred when a train derailed in East Palestine. When this train derailed, thousands of gallons of toxic chemicals were poured into nearby water supply. Today, we will be talking about finding unknown compounds in water using light spectroscopy, which can be used to detect chemicals in your water supply. The purpose of this lab was to determine the contents of 3 different solutions in water using infrared, or IR, and nuclear magnetic resonance, or NMR, spectroscopy. The equipment used was the Nicolette IS5 FT IR KBR salt plates and the EFT60 NMR spectrometer, which were prepared on deuterated chloroform at 60 MHz. And this lab follows the Chemistry 120N Concepts in Chemistry Laboratory Manual. So how is IR spectroscopy used? Well, IR is able to find the functional groups of a molecule. So if we look at the Lewis structure over here, we can see that there are 2 different functional groups here. We have a CH and an OH group. IR is able to, it shoots an infrared ray through a sample and then is able to read the absorbance. A CH group will have a different absorbance than an OH group. That will correspond to a wave number, and the wave number will correspond to the functional group. And using the Lewis structure, we were able to, for 15 potential molecules, we were able to predict what their results would be under IR spectroscopy. Here we can see what the exact wave numbers are for each functional group. So here are the results from the IR results sample for 4A. Here we can see in this fingerprint region, there are some wave numbers down here, but there is also a 3,1500 wave number. This corresponds to a benzene ring. Knowing that there is a benzene ring here can get rid of, or kind of lower the likelihood that the fingerprint region down here means very much. So from the table above, showing all the potential molecules, there are only 3 possible molecules this could be. It is mesylthylene, benzene, or paraxylene. So how do we determine which of the 3 it is? We use NMR spectroscopy. NMR is able to find the type and abundance of hydrogen molecules. So we can see here, there is a H over here, an H over here, and an H over here. There is, these hydrogens will be different from these hydrogens, which will be different from these hydrogens. There are also 3 of those type of hydrogens on the far left, and 2, and 1 over here. And it is able to read if there are different types, and it's also able to detect how many types, how many of that specific type there are. How it's able to do this, it excites the nuclei of these hydrogen molecules. This will raise them to a higher energy state, and then energy will be emitted from them being in a higher energy state, and an NMR spectrometer will read this. And this was again done for all the 15 potential molecules, but we are looking for sample 4A. We're looking at these ones specifically because from the IR results, we know that it cannot be any of these. And the NMR results, well, we can see that there are 2 different peaks, and there is a 3-to-1 ratio. This means that there are 2 different types of hydrogen, and one type of hydrogen will have 3 times as many more hydrogens than the other. If we look at the results, if we look at benzene, we know it cannot be benzene because there is only 1 peak in one type of hydrogen in benzene. If we look at paraxylene, there are 2 peaks in this. However, there is a 3-to-2 ratio, which is different than the results we got for 4A. which leads us to knowing that this molecule is most likely mesylthioline. So this was done for 2 other molecules, and they were identified to be 1,2-dichloroethane and T-butanol. So what are the consequences of having these chemicals in your water supply? Mesylthioline has a relatively short half-life, but in the time that is spent in surface water, it is found highly toxic to aquatic life. T-butanol has been known to not cause very many serious consequences or side effects in surface water. 1,2-dichloroethane, however, has a half-life of 6.1 to 72 years, and it is extremely toxic and has been known to kill aquatic life. And the human health impacts, mesylthioline has been related to central nervous system damage, and there are no reported deaths from it, but it can lead to irritation, skin irritation, and a burning sensation. Similarly to its results its effect in surface water, T-butanol is not that, doesn't have that many negative effects. It does have some mild irritation when inhaled, but other than that, it is not that unsafe to be drank. 1,2-dichloroethane is associated with an increased risk of cancer, and it is consistently tested for. And these are from the U.S. Environmental Protection Agency, the National Institute of Occupational Safety and Health, and McGregor-D. So in conclusion, to understand water testing, we use IR and NMR spectroscopy. We consistently test our waters to make sure that there are no toxic chemicals in there affecting our health and the environment. And that's all I have for you. Thank you. References. That's a bad conclusion.
Okay. I think you got it.